Hello class, for today you'll be learning the recursive formula. That will be the main topic for today. The main difference between the recursive formula and the explicit formula is that you will be using something called a previous term, in which what we're going to be talking about. We'll still be doing arithmetic and geometric, and you'll just be taking a small quiz on Thursday dealing with the recursive arithmetic and geometric sequences, and that will be it. Starting next week, we're going to be starting something called series, and that's going to be using the Greek symbol called sigma, and it's going to be the summation of sequences. We are still under the topic of sequence. Series is what we're going to be doing next week. So for this table here, I would like you guys to jot down some notes. The current A term is notated always with the a sub n, with the subscript n indicating the nth term of the sequence. Okay? So the value here, the small value that's indicated by n, is always notating the term. So if it's a sub 1, that's the first term of the sequence. If it's a sub 10, that's the 10th term of the sequence. And that's how it was always been. Now, if we take that part of the expression and apply it here, when we're talking about the previous term, the way that we notate it is the a is going to be n, and the term that's going to be represented previous is you're going to always subtract 1 from it. So if we're talking about a sub 10 as the current term, the previous term should be a sub 9, right? So the way to indicate that is a sub n minus 1. And what I would like you to do, the a looks pretty weird, so I'm just going to do this. Just write that it's a sub n minus 1 for the previous term. Now applying the same topic here, the next term would be a sub n plus 1, and that would indicate the a sub 11. Okay? All right, so first have these three terms written down, and then before that, after that, I'm going to move on to the next topic here. The explicit versus recursive sequences and definition. Explicit formula for arithmetic, as you already should know, it's a sub n is equal to a sub 1 plus common difference d times n minus 1. Now the recursive formula for arithmetic would simply be that it's a sub n minus 1 plus d is equal to a sub n. So what that means is some of you guys had already this format in your homeworks and quiz. You're going to take the previous term, and then you're going to apply the common difference d, and then it will get you the next term, right? So in a nutshell, it's easy to understand. However, when we write it, there is a ways to write it in two different ways. So what's the point of writing a recursive formula when we're already given the explicit formula is that recursive formula always uses what we call the previous term, and it's recursive, so it means it's recycling. I like to call it recycling the previous term over and over again to get to the next term. So generally speaking, there's really not that much of a big difference between these two. However, if they're really specifically asking you for the recursive, you need to understand that it needs to incorporate the a sub n minus 1 no matter what. Okay, it's gotta use that no matter what. So for geometric, let's go over. The explicit formula will be a sub n is equal to a sub 1 times r to the n minus 1. For geometric, for arithmetic, would be simply take the previous term, and what do we do with it? We multiply by the common ratio r, and that's it. So these two would be the new formulas. 1, 2 for recursive formulas for the sequences. Let's try some of these questions, and I'm going to give you one question for arithmetic and one question for geometric to do, and that's going to be it, but you need to write down the recursive formula for those two. Okay. All right, so we're talking about arithmetic sequence, and let's take a look at this sequence here. What's my common difference? My common difference is negative 30, because it seems like I'm subtracting by 30 all the time. And so I can simply use that, my recursive formula expression, a sub n equals a sub n minus 1 plus d. So my recursive formula will be a sub n is equal to a sub n minus 1, the previous term, minus 30. Now, if I were to use the explicit formula for this, you should say a sub n is equal to negative 28 plus the common difference minus 30 times n minus 1. Now, what should happen here is that a sub n is equal to, some of you guys distributed these and got negative 28 minus 30n plus 30. Okay, but this would simply mean that it's going to be 2 minus 30n, and that's the sum of the answers that you have. But these two are two completely different things, because we are talking about the previous term, a sub n minus 1, and we're going to be recycling over and over again to get to the answer. So when I give you the recursive formula to find out the next term and so forth in the sequence, you cannot just simply say, okay, I want to use recursive formula to find out the 17th term. You cannot simply just plug it in to the explicit formula to find the 17th term directly. We can't do that. Because for this, the recursive formula, you need to start from the first term, because you need to be given that the a sub 1, which would, let's say, was negative 28, and then to find the a sub 2, we need to use the negative 28 and then subtract 30 from it, which gives me negative 58. And then so you're recycling it over and over again. You're plugging it in back and forth, plugging it in back and forth to get the next several terms in the sequence, and you can't get to the 17th term directly other than keep on doing it 17 more times. So that is not really the useful part of it. But so then what's the whole purpose of it? I just need you to know how to make the recursive formula in the first place. Okay? So for, let's say, for this one here, I'm going to give you guys this to do for homework. Find the recursive formula for each geometric sequence. For this one, you just have to identify that the common ratio is negative 3. So all of you guys are still not following the directions and just telling me that the common ratio is positive 3 for some reason. That is not correct. Positive 3 means it should be 1, 3, 9, and 27, not 1, negative 3, 9, negative 27. So my explicit formula here would be a sub n equals a sub n minus 1 times negative 3. And that's it. That's the recursive formula. Okay? And that will be your homework for the day. Now here, find the first 5 terms determined by the following recursion formulas. That would be how you find out the difference between the recursive and explicit. And so let's say I gave you the first term in the sequence, and let's say that this is going to be the sequence that's following provided. Now notice that if you're given something like this, you are not going to get a arithmetic nor geometric sequences, because it's not going to be a common difference or a common ratio question. So for example, let's say I wanted to find out a sub 2. That means it's 2 times a sub 2 minus 1 plus 4, because n value is 2 and I can just simply plug it in. A sub 2 then is 2 times a sub 1 plus 4, and notice how that would mean my previous term. So a sub 2 is 2 times 1 plus 4, which gives me a 6. So my first term in the sequence is 1. My second term in the sequence is 6. What about a sub 3? 2a sub 3 minus 1 plus 4. Remember, I plug in n as 3. A sub 3 is equal to 2 times a sub 2, the previous term. A sub 3 is 2 times 6 plus 4. So then that's 12 plus 4, which is 16. So my third term is 16. Now notice how this term sequence, if I were to do the same thing over to find a sub 4, blah, blah, blah. Fourth term, fifth term, sixth term, and this can go on and on and on. This is not arithmetic, because it's not plus 5 all the time. It's not times 6 all the time. So it's neither arithmetic nor geometric. So what is recursive formula really useful for? It's for the sequences that is not necessarily arithmetic nor geometric. because this component has multiplication and addition, which means it's like a mix of both arithmetic and geometric. And if you have a sequence ever like this, when we say it's neither of those two things, there you can still represent the sequence by using what we call the recursive formula. Okay, so that is the useful part of recursive formula for those of you who are still asking that. But remember, your main job is to really come up with the recursive formula for these two questions here, and that's going to be it for today. I'm going to give you guys the quiz on Thursday. Let's do on Friday, only on recursive formulas and how to do these questions. Thank you. Have a great day.